In this video, we are going to study functions by looking at toothpick patterns. Let's begin. So we need to build the following patterns with toothpicks. We're going to study these patterns and then build and draw figures 4 and 5, use our information, and then complete the table at the very bottom. So this table down here. So imagine we've got 3 toothpicks right here to draw our first pattern. That's 1, that's 2, that's 3. This is 4, 5, 6. Sorry, not 4, 5, 6. This is 1, 2, 3, 4, 5, 6 right there. Looks like we're just building triangles. So if we were to get toothpicks, we build that first one, the second one, the third one, and then what would the next pattern look like? Well, we'd need 3 more toothpicks to draw a 4th one. And what would the 5th pattern look like? Well, we've got 3 toothpicks. It's everything we had before, except we're gonna build a 5th triangle with toothpicks. So in figure number 1, we're using a total of 3 toothpicks. Figure number 2, we're using 6 toothpicks. Figure 3, we're using 9 toothpicks. Figure 4, we are using a total of 12 toothpicks. Are you seeing the pattern here? So number 5, we are using 15 toothpicks. So figure 1, 3 toothpicks, then 6 toothpicks, then 9, then 12, then 15. So if we drew a 6th pattern, how many toothpicks would we need? Well, it seems like we're just adding 3 more. So we would probably have a total of 18 toothpicks. Now, if we were to do a 10th figure, so from 1, 2, 3, 4, 5, 6, all the way up to 10, how many toothpicks would we need? Well, what's the pattern here? How do I get from 1 to 3, or 2 to 6, or 3 to 9? I need 3 toothpicks each time. So basically, I'm just multiplying by 3. Every time I multiply by 3, I get the number of toothpicks. So 1 times 3 is 3, 2 times 3 is 6. If it's the 3rd figure, multiply that by 3, I get 9. So if it was figure 10, multiply that by 3, I get 30. So n is a mystery number, but how would I figure out the number of toothpicks? Well, you do the same thing. You multiply by 3, and so the number of toothpicks would be n times 3. Or, more common way of writing that would be 3n. Sorry, that's not a very good 3n. Let's look at figure pattern B. Number 1 has 4 toothpicks. Number 2, it looks like we're doing 4 more and then 4 more. So let's do, it's our 4th pattern. It's 2 diamonds, 3 diamonds, and then we would have a 4th one. So our 5th one would look like this. So figure number 1 has 4 toothpicks. Number 2 has 8 toothpicks. 3, we needed to add 4 more, so that's 12 toothpicks. And you may see the pattern already. You needed 4 more toothpicks, so that's 16. And 5, that would make 20 toothpicks. So figure 1 had 4, then 8, then 12, then 16. You may see the pattern already, 20. So basically, you just need 4 more, so that's repeated addition. If you're repeatedly adding 4, it's the same thing as multiplying. So if you multiply everything by 4, if you multiply 6 by 4, you would have 24 toothpicks needed for the 6th figure. If you had 10 figures, multiply that by 4, you would need a total of 40 toothpicks. So if you had n figures, you multiply that by 4. So that is n times 4, or 4n. Let's look at a couple more figures. C and D. It's a little bit different. So we start off with a triangle. And then looks like inverted triangle. And so let's do this. So we have this 1, 2, 3. So that's the same pattern. And it looks like we just have to add another triangle. And then the 5th pattern would look very similar. So this is the pattern above, but I have to add another to make the other triangle. So I'm using 3 toothpicks here. And number 2, I'm not using 6. I'm actually using 5. So it's like 1, 2, 3, 4, 5 toothpicks. So if that's 1, 2, 3, 4, 5, I'm adding 7 now. And then for the next one, 1, 2, 3, 4, 5, 6, 7, 8, 9. And what is the change? How much is it going up each time? Looks like I need another 2 toothpicks every time. So the first one had 3, and then every other one had 2 more. 5, 7, 9, 11. So how much would the 6th figure have? It'd have 13. How much would the 10th have? Well, let's see. If we're just adding 2 each time, adding 2. So you can't just say you're multiplying by 2. You can't say what's going on is I'm just multiplying by 2 every time. Because it's more than just multiplying by 2. Because if I multiplied 1 times 2, that doesn't get me 3. But what if I multiply by 2 and I add 1 more? Would that get me 3? It would. What if I multiplied 2 by 2 and added 1? 2 times 2 is 4, plus 1 does equal 5. 3 times 2, that equals 6, plus 1, that's 7. So that looks like that's the pattern, is I still am going up by 2. So I'm multiplying by 2 because that's the repeated addition part. But I have to add 1 more to it. So if I did 10, because I'm adding 2 every time, which is repeated addition, which is multiplication. So I multiply by 2, and I have to add 1. So that's 20 plus 1, that's 21. So that's what I'm going to do with n. I'm going to multiply by 2 and add 1 to it. So you can say it's n times 2 plus 1, or a better way of writing that, 2n plus 1. Let's take a look at the next one, which is very similar. So it looks like we've got boxes, 4, 5, 6, 7, 8, 9, 10. And then if I want to build a 4th box, I need 3 more toothpicks. So that's 1, that's 2, that's 3. It's my 4th box, and I need to build a 5th box by adding 3 more toothpicks. So it looks like I start off with 4 toothpicks, and then I do 1, 2, 3, 4, 5, 6, 7. So I have 7 toothpicks. 2, 3, 4, 5, 6, 7, and then 8, 9, 10. So it looks like I'm adding 3 more every time. So if I add 3 more toothpicks, I have 13. 3 more is 16. But I start off with 1. Oh, sorry, start off with 4. And then I add 3 more, which is 7. Add 3 more, 10. Add 3 more, 13. Add 3 more, 16. If I add 3 more, I'll have 19. What about 10? What is my pattern? Well, I'm adding 3 more every time. So that's repeated adding of 3 is basically multiplying by 3. So it's 1 times 3 doesn't get me 4. But if I add 1 more, can I use that same pattern for all of them? If I multiply 2 times 3 plus 1, let's see. 2 times 3, that equals 6, plus 1. Yeah, that gets us 7. How about 3 times 3? That's 9, plus 1, that is equal 10. So if I multiply 10 times 3 and add 1, that's 30 plus 1, 31. Do the same with n. Multiply by 3, add 1. That's 3n plus 1. All right. Now, what we need to do on our next section is we need to use the graph below and graph the coordinates from each of our tables, as many as they would fit, use a different color for each one. We need to graph each of these tables. Now, remember, each of these tables forms a coordinate pair. So, for example, this is my x term, and this is my y term. And so my x term, my coordinate pair would be 1 and 3. 1, comma 3. And you can graph that point. My second one would be 2, 6, and 3, 9. 2, 6. 3, 9. And so on, 4, 12. So let's graph those points. 1, 3, 2, 6, 3, 9. So 1, 1 and 3, 2 and 6, 3 and 9. And then the next points would be 4, 12, 5, 15, 4, 12, 5, 16, sorry, 5, 15, and then 6, 18. And then I can't graph anymore, but I need to draw a straight line through all of these points. So I'm going to pull a ruler down, draw a line through these points, and I actually need to draw a line through, let's see. If I was able to draw straight enough, I need to draw a line that cuts through all the points. So it would end up looking like this, and this is figure A. So figure A looks something like this. It's not the greatest line in the world, but it is good enough. Figure B, table B, we've got 1, 4, 2, 8, 4, 12, 1, 4, 2, 8, 3, 12. And you can actually see that, remember, you add 4 more toothpicks each time. So you add 1, 2, 3, 4 toothpicks for each new figure. And then I could go 4 more toothpicks up and go 1 over. Draw a line through that. And that is B. With C, I've got 1, 3, 2, 5, 3, 7. Start off at 1 and 3, which actually overlaps. 2, 5, 3, 7. And if you remember, it just basically, I'm adding 2 toothpicks each time, every time I go up another figure. So I can just do it that way. I can go up 1, 2, and then go over 1 figure. So add number of toothpicks, go 2 up, and go 1 over to the figure number. 2 up, 1 over, 2 up, 1 over, 2 up, 1 over, 2 up, 1 over. If I draw a line straight through that, that will end up with a line that looks something like that. Let's do our last one. We start off with 1, 4, 2, 7, 3, 10. If I remember, it's like adding 3 toothpicks each time. 1, 4, 2, 7, 3, 10. 1, 4. 1, 4, which overlaps. 2 and 7. 3 and 10. And I'm adding 3 more toothpicks, so I go up 3 and over 1. Add 3 more toothpicks, go over 1, add 3 more toothpicks, and go over 1. So my line ends up looking something like this. And that is line D. All right, so I've got my 4 graphs. And we're going to answer some questions, not all of them, but are all these toothpick patterns functions? Explain clearly using the data of what defines a function. Well, we could prove it 2 ways. We can look at the graph and we can ask ourselves, does it pass the vertical line test? It does. None of the graphs zigzag like that. They don't curve around or anything. They just kind of go straight in one direction, and it does pass the vertical line test. We can also say it's a function by looking at the tables and notice the first value or the x value does not repeat. So you can prove it 2 different ways. You can say, yes, they are functions. And graph passes vertical line test. Vertical line test. And tables don't repeat x's. Don't repeat x's. Are there any patterns that are proportional relationships? We're not going to really talk about 3 or 4, but just know that these 2 ones are not proportional. The C and D are not proportional, but A and B are. A and B are just multiplied by a number, whereas C and D are multiplied and you add another number, so it's not proportional if you have to add or subtract a number. But if all you're doing is multiplying by the mystery number. It is proportional. So not super important yet. Are they proportional? No, they are not. Sorry. 2A and B are proportional. B and C are not. Let's answer question 4. Do all 4 toothpick patterns have a constant rate of change? Yes, they do. Remember, constant rate of change, a straight line indicates a constant rate of change. Oh, darn it.